Now that was fun. I'm Sean D. Tucker and I make my living as an airshow performer. My friends at Hartselle asked me to talk to you about prop safety. And since my line of work requires me to hang everything on my prop, I jumped at the chance. Obviously, during my airshow routine, this prop is subjected to tremendous stresses. Although the average pilot does not fly like I do, what you may not realize is that on a flight to the airshow, my Cherokee 6 prop also sees very high stresses. For example, just the centrifugal force on a blade is over 18 tons. That's like the weight of 11 mid-sized cars pulling on each blade. Add to that bending, flexing, and vibration, and you'll understand why the prop is the highest stress component on the plane. Unfortunately, many times the prop doesn't get the attention it deserves. When was the last time someone took a good look at your prop? There are 3 opportunities to inspect your propeller: your pre-flight, at the annual, and at overhaul. Give these inspections the attention they deserve. Now I'll let the experts from Hartselle give you the information that you need to help ensure that you're flying behind a safe prop.
A basic propeller consists of a central hub unit, blades, and a hydromechanical pitch control mechanism. While in operation, the propeller is one of the most highly stressed components on the aircraft. This model shows some of the stresses placed on a propeller during operation. The areas that are red are highly stressed, and the blue areas are areas of lower stress. This model represents centrifugal force only. Now, we'll add the aerodynamically induced stresses that occur once each propeller revolution. This stress is caused by the flexing of the propeller blade as it pulls the plane through the air. At 2,700 RPM, this stress cycle occurs nearly 400 million times by the time the propeller reaches a 2,400-hour TBO. Other stresses, such as those caused by the firing of a piston engine, can occur many times per revolution, exposing the propeller to billions of stress cycles by the time the propeller reaches overhaul. Certified propellers are designed to withstand these stresses throughout their life with proper routine maintenance. Design alone, however, cannot compensate for the impact of a nick, gouge, areas damaged by corrosion, or general neglect. This sequence shows how blade stresses can concentrate around a nick in a blade. Damage like this increases stress on a propeller and can weaken the propeller and cause failure, especially when the damage occurs in an area that is already highly stressed. In general, propeller manufacturers have specified 3 types of scheduled maintenance to help ensure flight safety and long product life. These are the pre-flight inspection, the annual inspection, and propeller overhaul. A pre-flight inspection of your propeller is important to ensure your safety, and directions to perform a thorough pre-flight inspection are in your propeller owner's manual. Before your next flight, take a few minutes to look it over so you know what to look for. If you have any questions about your pre-flight, talk to your mechanic or call the manufacturer. Here are some things to look for when doing your pre-flight inspection. Look for nicks and gouges on the blades. Any damage greater than 1/32 of an inch should be dressed out before further flight. As a general guideline, if you can catch your fingernail on a nick, it should be repaired before you fly. All propellers should be painted as the manufacturer requires. Look at the paint on your propeller. Can you see any exposed aluminum? Bare aluminum exposed to the elements will corrode. This is a good time to talk about polished propellers. Polished propellers have no coatings or paint to protect the bare aluminum and are exposed to erosion and corrosion. A polished prop requires more maintenance and wears out faster than a painted one. There are no certified propellers that can be returned to service without a protective blade coating. Check the spinner for loose or missing hardware, cracks, and looseness. Replace the missing hardware as needed. If your spinner is dented, cracked, or otherwise damaged, have it evaluated by your mechanic before you fly. Check blades for excessive movement. Look through the blade openings in the spinner for evidence of grease or oil leakage around the hub. Any leakage should be evaluated by your mechanic before flight. Check your owner's manual. Consult a maintenance professional, or call the manufacturer if you have any questions that come up during your pre-flight inspection. Whenever the engine is running, be alert for any unusual vibration or leakage of grease or oil. If any of these occur, shut the engine down as soon as practical and investigate the cause. This can be an indication of a serious propeller problem. The second inspection type is the annual inspection. When you bring your plane in for the annual inspection, your mechanic will perform an inspection similar to your pre-flight inspection and some additional tasks. During the annual, your mechanic will remove the spinner and inspect the hub for cracks or evidence of grease or oil leakage. Check for proper blade track and confirm that any blade movement is within limits. Remove all nicks and gouges on the blade per the owner's manual and reapply the protective coatings as needed. Grease the propeller, if required by the manufacturer's guidelines. A shorter lubrication interval may be more economical if the aircraft is operated less than 50 hours a year, or if it is operated in salty air or a similar corrosive environment. Incidentally, if you grease your own propeller, use caution. Depending on the propeller type, it may be possible to over-service the propeller and cause grease leakage and/or vibration. The correct lubrication procedure is in your owner's manual. All of the propeller's external parts will be inspected for abnormal wear or visible corrosion. Your propeller shop will need to address any abnormal wear or corrosion. Finally, a thorough search should be performed to verify compliance with any applicable ADs and service bulletins. The third and most comprehensive inspection is propeller overhaul. An aircraft engine usually will provide clues that maintenance is needed, such as increased oil consumption, lower compression, or hard starting. Generally, your propeller will not provide any clues that overhaul or repair is required. Often, a propeller will operate normally right up to failure. That's why it's important to have your propeller inspected and overhauled as recommended by the manufacturer. This is one of the best ways to prevent propeller failure, and is necessary for continued safe operation of your propeller. Overhaul intervals are based on flight hours and calendar time. The flight hour interval is established to address stresses induced during operation, and calendar time to address corrosion and deterioration of seals. Because internal corrosion and the effects of stress cannot be seen, a propeller beyond its overhaul interval could have unseen damage that could eventually lead to failure. Remember, timely inspection and overhaul of your propeller is your best method to assure continued safe operation of your propeller. Recommended overhaul times for Hartzell propellers are located in Hartzell Service Letter 61. This service letter can be found on the Hartzell website.
All flying has some element of risk. It all comes down to how much risk we're willing to accept. I reduce my risk by using the best equipment and ensuring it's maintained properly. This gives me the confidence I need to perform at my best. You can reduce your propeller-related risk by performing a thorough pre-flight, having a proper annual inspection, and following the manufacturer's overhaul and maintenance recommendations. Remember, safety should be every pilot's #1 priority.